Chapter 9.3 is dealing with dividing and multiplying rational expressions. And so I want to get us started with something old. This is something that you guys already know how to do. And what we're going to do is we're going to multiply these two expressions together using some old stuff that we know. If I'm going to multiply these two together, what I want to do is I want to reduce as much as I can first. And I can reduce going diagonally or up and down. So if I reduce up and down, I know that 18 and 15 can both divide into 3. So what I do is I reduce them by 3. So what I get on top is 6 over 5. And I can also reduce diagonally because 4 and 6 are both even. So what I get is a 2 down here and a 3 up here. So when I finally am ready to multiply everything, when everything's all reduced, I get 9 times 3, which is 27, over 5 times, or 2 times 5, which is 10. And that's how we dealt with multiplying fractions. Now, what I want you guys to realize is that without really realizing it, if I rewrite this problem, 9 over 4 times 18 over 15, what you did is you identified 9 as 3 times 3. You identified 4 as 2 times 2. You identified 18 as, let's say, 6 times 3. And then 15 as 5 times 3. So what that allowed you to do was to cancel the 3's, cancel the 6 and the 2 to give you a 3 here. 3 times 3 times 3 is 27. 2 times 5 is 10. We got the same thing. Here is what was going on in your head without really realizing it. That is applied in the new stuff because the process at which we simplify rational expressions is exactly the same. And what we did first was this idea of breaking numbers apart is something you guys know. It's known as factoring. The next thing you guys did was you canceled, right? The 3's canceled out, the 6 and the 2. And then the last thing you did was you multiplied. Now, I want to go over the last two steps. Cancellation only happened diagonally or top to bottom. And then multiplication is straight across. So how does this apply to an algebraic rational expression? Well, if we look at the new stuff here, if I say 3x plus 6 over 7x plus 7 times 14x minus 14 over 5x plus 10, I'm going to go ahead and factor first. So let's factor everything. The top left is going to pull a 3, so I get x plus 2 on the inside. The bottom, I'm going to factor out a 7. That is x plus 1 on the inside times top right, I'm going to factor out a 14. That leaves me with x minus 1. And then the bottom, I'm going to pull a 5 out of there, so I get x plus 2. So let's see what I can cancel. I can cancel the x plus 2's. I can cancel a 7 and a 14. That leaves me with 2 up here. And x plus 1 and x minus 1, they're not exactly the same, so I can't cancel them. So if I'm done canceling, I'm going to go ahead and multiply. 3 times 2 is 6. And let's not forget our x minus 1 over 5 times x plus 1. And that's as far as you can go with that problem. Okay, let's take a look at example number 2 here. Let's go and factor the top left so that I can pull a 4 out of there, leaving me with x squared minus 1. But part of the reason why I want you guys to get used to factoring things completely is because this x squared minus 1 can actually factor yet again into x minus 1 times x plus 1. All of that's going to be over. Well, the bottom can't be factored, but I am going to expand it. And on the right side, I'm going to pull a 3 out so I get an x plus 1. And then the bottom, I'm going to pull a 2 out to get x minus 1. So let's cancel everything that we can. And x minus 1 is going to go away. And x plus 1 is going to go away. Another x plus 1 is going to go away. 3 will cancel with 9, leaving me with 3 on bottom. 4 is going to cancel with 2, leaving me with 2 up top. So when all is said and done, it's 2 over 3. And that is as far as you go with this problem. Let's take a look at our next example here. This is w squared over all this stuff times all this stuff. Let's go and just factor everything, and that's what we're going to have to do. That leaves me with w minus 3, w minus 8 up top. On the bottom, I'm going to end up with w minus 8 times w minus 10. Top right, I'm going to end up with w minus 5 times w minus 10. And then w minus 4 times w minus 5. Let's make this 3 a little more clear. Okay, let's go and cancel everything that is possible. W minus 10s are going to go away. The w minus 5s are going to go away. And the w minus 8s are going to get out of there. So what I'm left with is w minus 3 over w minus 4. Okay, let's move on to some division here. Dividing rational expressions is exactly like what we did before. And if I asked you to divide two fractions, let's say 1/2 divided by 7/8, you would simply just take the second fraction, flip it upside down, and then you'd factor cancel like normal. So your answer would be 4/7. So here, the operations are exactly the same. It's just like multiplication, except the first thing you're going to do is you're going to flip and then factor, then cancel, then multiply. All right, so let's go ahead and flip first. So 12x squared plus 6x minus 6 over 4x plus 1 squared times. So times. Now that I've factored the right term and changed this to multiplication, let's go ahead and factor everything. So let's go ahead and factor out a 6 from the top left. That leaves me with 2x squared plus x minus 1. That goes away. But this can be refactored again, so let's go 6 parentheses, 2x and x. I've got a 1 and a 1. The way I can create a positive x would be positive 2 and negative 1. All of that is over 4 times x plus 1. And I'm going to go ahead and expand just like we did in the last problem. Times, I'm going to factor the top right. And I'm going to factor the bottom left. Okay, so let's see what gets out of here. We can cancel out a 2x minus 1. We can cancel out an x plus 1. Let's see here. The 6 and the 3 can go away. I'm left with 2 up top. And then the 2 and the 4 cancel each other out, leaving me with 2 on bottom. And then vertically, the 2's can cancel each other out. So what that leaves me when everything is all cleaned up is x minus 1, because that was not crossed off, over x plus 1. Let's actually scale it down a notch. These problems are actually given before, but I like to do them afterwards because I just like the order. So from here, there's no explicit factoring like we did in the trinomials, but we will go ahead and just cancel everything that we can. Looks like 4 and 16 can cancel, so that leaves me with 4 on bottom. 7 and 21 can cancel, leaving me with 3 up top. A to the third and a can cancel each other out, but that leaves me with a squared. C squared and c to the third can cancel each other out, leaving me with c. B and b are going to cancel each other out. D and D are going to cancel each other out. So let's do it just like a preliminary cleanup here, because this is getting kind of messy. Looks like from the top I have left over a 3a squared c over, looks like 4c squared. Now I can go and cancel out my c's. I'm left with 3a squared over 4c. Okay, let's try another one. We're using some division. We're going to go ahead and flip the second one, so 5b squared c on the bottom times 3bc squared over 8a to the third. Okay, so now that we flipped, let's go ahead and cancel what we can. A squared is going to cancel with a to the third, leaving me with an a on bottom. 2 is going to cancel with 8, leaving me with 4 on bottom. B squared and B are going to cancel, leaving me with a B on bottom. C and C squared are going to cancel, leaving me with a C on top. And then 3 and 5, you can't really do anything with them, so let's just go and multiply across. That is 3C over 5 times 4 is 20. B times A is BA or AB. Complex fractions is the last part of this lesson, and with a complex fraction, it looks really complex, and so it's just like this four-stacked tower, and there's really no way to figure this out. But if you look at it, what we're saying is we're looking at the top fraction divided by, right, because that's what a fraction is, it's just division, divided by the bottom fraction. So what this really is this is really 5a squared minus 20 over 2a plus 2 divided by 10a minus 20 over 4a. And now if I gave you the problem that looked like this, you'd know exactly what to do. Let's go ahead and flip everything on the right. And let's go ahead and solve this like we normally have been. Here I'm going to factor out a 5. I get a squared minus 4, which means I can refactor the a squared minus 4. So that is 5 times a plus 2, a minus 2. Factor out a 2 on the bottom, a plus 1 times 4a over 10 times a minus 2. Cancel everything that we can. These go away. Whoops, that doesn't go away. Let's see. These are going to go away. You get a 2 up top here. The 5 cancels with the 10, leaving me with 2, and the 2 and the 2 are going to cancel, leaving me with a times a plus 2 over a plus 1. Let's do another one of these. In this next example here, we've got another 4-layered fraction here, so let's go ahead and just rewrite it in terms of something that we already know how to do. And actually, we can even bypass the whole division because it's really just the top thing times the bottom flipped. So it's going to be times 2x plus y over x plus y. This thing here, it doesn't seem like it can be factored that much, but remember, I've got x plus y's up top and bottom, and they're in a group, so they can go away. And from here, I end up with 2x plus y over 2x minus y. Please do not do this. Right? That is not true. You cannot cancel the two x's. You cannot cancel the y's because they are being added and subtracted on top and bottom. This really is the answer. As distasteful as it is for you to leave it like that, you have to leave it that way. You cannot simplify this any further. And the last example is this problem here. Let's go ahead and just rewrite it in terms of something we understand. Times the flipped version of the bottom, so that's 4y squared plus 4y over 3y minus 3. Let's go and factor everything. Pull a 6 out of the top, and that's y squared minus 1. That can be refactored into 6 times y plus 1, y minus 1, over, factor out an 8y here, I get y plus 1, times, factor out a 4y, I get not y squared, y plus 1, and then I get 3 times y minus 1. Let's cancel everything that's possible. That goes away, that goes away. The y minus 1s are out of there. The 4y and the 8y cancel, leaving me with 2. 6 and 2 cancel, leaving me with 3. 3 and 3 cancel, leaving me with y plus 1. Okay, that about does it for this lesson. We'll see you next time.